Okay. In the last session, we saw how to create processes and also a small demonstration of how a thread can be created within a process. So let's get the concepts pretty clear. So process can give rise to another process through the fork system call. We have seen this. So this is the parent process, this is the child process. So as you can see, each process works within its boundary. So the process space of a parent is very different from that of the child. So they don't share any common memory. If at all they want to communicate, we have seen the inter-process communication mechanisms, namely the pipes, the message queues, and shared memory. But this separate process, if you have and if whenever the executions happen within these process spaces, the context switch takes enormous amount of time. So the processor has to do a context switch. That is, if the processor is attending to the instruction here, after some time it has to switch to this. So the entire process space switching has to happen. So all the processor registers have to be revamped, and again execution should continue. And then again, when you want to go back to the parent for continuation, again the context switch has to happen. So there is a overhead associated with this context switch. And this is not acceptable in a real-time scenario where the switching between two execution paths have to be pretty fast. So to alleviate this, what is done is that they have brought in the concept of a thread. So we know that a process will have one execution path like this. So instead of creating a separate path of execution in another process using fork, I can create multiple execution paths like these. So these are called as threads. Okay. Threads are basically multiple execution paths within the same process. And these multiple execution paths can execute concurrently. It means on a time shared basis. Few instruction of this thread will execute and then switching will happen to this thread and then to this thread and again come back to this thread like this. So all threads will proceed concurrently. Okay, assuming that there is only one processor. If you have multiple processors, then each thread can run on different processor. That's a different scenario, but traditionally, assuming there is only one processor, this processor has to switch between the threads. Now, as I can see, the boundary of the process is same for all the three execution paths. So the switching is pretty fast. Okay. So that is why the threads are also called as lightweight processes. Okay. Is the distinction between process and thread is clear to you? Hello? Okay, so this diagram you should keep at the back of your mind whenever you work with threads and processes. Okay, so in my previous session, I showed you how to create a thread. Let's quickly revise that. So you open up a, WSL console and open a file. Okay, so you need to have a header file called as pthread.h. So
Yes, sir.
pthread.h has
Yes,
all
sir.
the system calls definitions using which you can create the threads. So you need to write a thread handler. So the thread handle syntax is like this. Okay, so it returns a generic pointer. You can give any name to this. So you can say handle thread. And it accepts a generic pointer again. Why it is generic? we'll discuss shortly. And within this, it has to execute the code belonging to the thread. So let's say we just want to say hello world or something. So you can do that. And you can print whatever message that has come from the main thread. Okay, so we can use this. What I can do is I will msg, sorry, char star msg. Now, since rguess is generic, you have to typecast it accordingly. So, since I'm sending a character pointer, I have to typecast like this. So, whatever the main thread sends through this argument, it has to be typecast appropriately. It means I'm sending a character strings, and that message will be printed by the thread within the process. So, and before you return, since the return type is of a pointer, it has to be null pointer. Or it need not be always null. If you have declared a structure here with some data members, it can be address of that, so that any process data can be returned back to the main thread. So this is a simplest handler that we can have. So just note the signature of a handler. Handler return type should be generic white star. The argument should also be generic white star, so that you can pass data of any type and typecast it accordingly. You can send an integer, you can send a string, or you can send a float type data or double type data, and accordingly the typecasting has to be done within the body of this handler. And before you return, you should return some pointer. Since there is nothing to return, I'm just returning null here. Okay. So in the main, I have to declare a thread descriptor. So pthread underscore t is a defined constant within the pthread dot h. So in this header, there is a data type declared pthread underscore t. So you should declare a variable of that type. And here you should create the thread. So pthread create, and you should pass the address of the thread ID. The second argument should be null, or it should be a structure variable. We shall see that. For now, it just put null. And third argument should be the name of the handler. So handle thread. And the last one is the argument which is coming within the thread handler. So here I need to declare just this, and this message has to go as the last argument. Okay, and after you have created the thread, and if you want the main thread to wait for it, then there will be a pthread wait, and again here it can be null pointer. So I'm just creating a single thread within the main process. The main thread will be there, and the child thread, which is within the same process space, will be created, and this function will be called automatically. And after that function is over, the main will be waiting here. Pthread, I think so it is not pthread wait, it is pthread join. Yeah, it is pthread join. So that the main thread will wait for the thread to come back. Join. Here, yeah, yeah. It's not process ID, it is the thread ID. Thread ID. And is there a second argument? I think so. It's only just this. So let's check how it pans out. Compile this.
Sir, for join, it would
Thread
need the
one dot
process ID,
c
right?
minus o.
Huh?
Yeah. There is a second argument which should be null.
Thread, okay.
As you can see, hello world is what I typed in the function, and good afternoon is the message which came from the parent thread or the main thread which created this thread. Okay. So is the concept of creating a thread is clear, or you have some doubts here? Just observe one more time that thread here. See, the thread priorities can be set. Every thread can have its own stack. Okay, and every thread there are certain parameters to be set. Okay, so I'll get to that. There is one more program I'll show you. So there is a pthread attribute
Sir, just repeat about why we
variable
pass
which you have
null
to
as a
declare,
second argument.
and there you can specify how much stack space you want for the
Above
thread.
in create thread.
Okay, and what priority should be set. Okay, and what scheduler you want to choose, whether you want round robin scheduler or you want first in first out scheduler. So you can choose a scheduler for the threads also. So all that can be specified as the second
Okay.
argument. Okay, so I'll describe that when I take up another program wherein how to set these parameters. So for now, you create the thread and you execute. At this point in time, the new thread will be created and the thread executes, and the main thread will wait until the thread completes, which you have written here. And you can pass any value to the thread that is created to the fourth
Okay.
argument here. Okay. Now let's take another more concrete example where
Sure.
I want to create two threads, and
Okay,
one
sir.
thread will do up counting, another will do down counting. So we have up, down one dot c. Yes, some template program here. Now I want two handlers. I will not call them handler functions now. I can name them as up counter and down counter. Okay. So here again the argument can be void star. So the up counter can receive a count value. So here I can declare star n1 is equal to int star r guess. so that this up counter will count values from, let's say, 1 to n1. So we can set up a for loop here for I equal to 1, I less than equal to n1, I plus plus, and print that percentage d slash n, comma I. So this will do up counting bit of. Likewise, I can create a down counter. And before you close this, you should return, because there is nothing to return. Here, void star down counter int star argus. Here again, I declare int n2 or sorry, star n2 is equal to int star argus int I. So this will be a down counter. So for I is equal to n2, I greater than equal to 1, I minus minus, printf percentage e comma I turn no. Okay, so writing handlers is this simple. Depending on what you want to do within the handlers, you have to write handlers above the main function. Now within the main, I have to create two threads now. For each thread, I require one pthread variable, pid1, pid2. Okay, and I need to create. Okay, we require two variables also. Int then 1 is equal to 10 and 2 is equal to 8, let us say. So up count will go from 1 to 10, down count will go from 8 to 1. So here I create the thread create. First argument is address of the ID. Second argument is null. Third argument is the handler. So here up counter. And last argument is ampersand n1. Okay, in my previous example, message was pointer itself, so I was just writing message here. Since n1 is a variable, I am writing ampersand n1. Similarly, I should create one more pthread create ampersand pid2. Now, down counter ampersand n2. And now you have to main thread has to wait. So pthread join pid1 pthread join pid2. Okay, so you can give a message. I am main thread terminating after two child threads completed. Some message like that. And before you start the threads, you can give one more message here. Printf, I am main thread creating two threads. Okay, so this is the complete program of the process initiating two threads. And to compile this is C down one dot C manage one. Something went wrong. Let's check. Yeah. Now I have declared n1 of type pointer. I should be using star n1 because I want content of the memory, isn't it? That is one thing. Down counter, down counter C should be capital here. Okay, this should be wide, right? So both should be of type wide. Okay, so that mismatch was happening. Okay, it went fine. Up, down, one, like this. As you can see, the up counter starts 1, 2, 3, 4, 5, 9, 10, and the down counter starts 8, 7, 6, 7, 1. And I am main thread terminating after two child threads completed. Is this clear now? How two threads can be initiated? Will you be able to do this? Just that you should get acquainted with the syntax and be careful about the types here. So both should be of generic types. Okay. The reason why the argument to handlers is void args is that in C there is no template class. In C++ we have templates, right? Okay.
Yes, sir.
So if this same program were to be written in C++, definitely instead of void star arg, we would have used some template. Okay. T,
Okay.
T arg, something like that. So that T is of some generic type, but C doesn't support generics. And that is why they are using void star. Hmm? Okay, so it's not that you can pass only of type int or char star. Okay, you can send a address of a structure also. For example, here you define a structure. Let us say uh, item. So within this, you could have int x, then float price, something like this. So this is a structure, and if you create a structure variable struct item T1, you can pass the address of T1 also here within this thread. Okay, of course, at the receiving end, I should handle it appropriately. Hmm? So since the argument is of generic type, you can pass intrinsic basic types like int, char, float, double like that, or it can be user defined like this tracked item and all this, so that we have two values passed as part of this item T1. All right. So this should be correctly noted. Do you have WSL on your system? Hello. Uh, do you like to try this out? Just give a try, because just going ahead with something. Yeah. Just see if the Nano editor is installed. If not, you say sudo update install Nano.
Yes, sir. Uh, got it. Okay.
Arpita, you have WSL?
Yeah, we'll give a try.
Yours is Mac, no? Huh. Because that operating system, if it is not POSIX compliant, then it may not support this code. See, the letter P here means POSIX. There is a standard for Unix operating system called as POSIX, Portable Operating System Interface. So if the operating system is POSIX
No, sir.
compliant,
No, sir. Mine is
I don't know
Mac.
whether
So
Mac
I'm
is
just
POSIX
checking how to
compliant.
do.
Most of the time it will be POSIX compliant. If so, the same
Yeah.
program should run on Mac also. You just have to type and compile and see. Yeah.
Hmm.
Ilpa, Pooja, and Ankita, you have WSL installed? Okay. Okay, good. That's good. Yeah. So one small thing here. This second argument in pthread join
Yeah,
is
I
null
have,
again.
sir. I'm trying it out.
Now, what is this for? As I told you, the handler will return a pointer.
Even I
If
have,
I
sir.
want to catch that
Yeah,
as a
I have
result,
searched.
we can do that. I'll show you here. Let's say I want to capture the result of second handler. So we declare a generic pointer here. And
Yes.
here, let's say in the down counter, I declare sum equal to 0. And within the loop, I just add up the numbers. Sum plus equal to I. And instead of return null, I can return the typecast version of sum. So what happens is this sum will be returned by the down counter. Okay. And here I have to get it uh, into the result. So here it should be in the result. And if you want to display this printf, the result returned is percentage %d result. I think so. It should be correct. Just a minute, I'll check. Pthread line. This should be just the address, and here it should be install, because you are returning a generic pointer that should go directly into this result2. Okay, and here it will be typecast into integer, and you are displaying it here. So let's see whether that is happening. Anyway, I'll get into the details of this next time. What is important is any handler can return some value or address of some variable here or some fixed value, and that value can be stored locally in the main thread. So main thread can receive the result computed by a thread which it has created. This is how the threads can communicate with each other. Okay. So the second argument here has to be address of another variable that is declared here. So now what we have seen is threads executing perfectly, appearing to be in a very synchronized way. Now, if you observe the execution of the program uh, here, one minute, I'm explaining this. So now, if you observe the output of this, the two threads appear to be perfectly synchronized. Your down counter is working first and then the up counter. Okay. But this is a exceptional case, that is by chance it has happened because the processor is very fast. It is giving enough time for up counter to do this. If I increase the count value, the synchronization may not happen perfectly. Just to introduce some bit of uh, synchronization disruption, I can make this thread sleep for some time. Let's say 1 second. So up counter sleeps for 1 second and down counter also sleeps for 1 second. Now what happens? Now the synchronization will not happen perfectly the way it happened in our previous case. Suppose if I compile this and run again, you will see that the output of the two counters get mixed up. So the up counter 1 comes, then down counter 8 comes, then up counter 2 comes, then 7, 3 like this. So the two threads output get mixed up. This is because the two threads are taking different amount of time. Now how do I perfectly synchronize these two? If you remember in C++, we discussed threads, and again when it came to synchronization, we thought of using the mutex variables. Okay, so do you still remember what mutex variables are? Mutex stands for mutually exclusive. So what should ideally happen is when one thread starts, it should block the other thread from executing. And only when it notifies to the other thread which is waiting, okay, the waiting thread can wake up and then continue execution. Okay, so there is a version of up down counter which is synchronized. So let me show you that. Up down synchronize. So what all changes I have to do to get the two threads synchronized? It is the same program. I have sleep for 1 second here. Additional code that is required to do synchronization is that you have to declare two variables, pthread mutex t, okay, and you declare a variable log, and you have to initialize it, pthread mutex initializer. Similarly, you should indicate what is the condition of the current thread. Is it done or it is still executing? So you have to declare a done variable. Again, it's called as a condition variable. And then there should be a global variable which indicates that the other thread, whether one of the thread is done or not. So up done is initially 0. It means it is still not done. Moment it is done, the child knows that another thread knows that the execution of the up counter is over and it can continue the down counting. So here observe what I'm doing is that first you have to create a lock, pthread mutex lock, and then pass this variable ampersand lock. And since you have done executing the entire loop here for I equal to 0 to n, it is starting from 0, that is a different thing. You can make it start from 1 and go up to n. And then up done is 1 and pthread condition signal ampersand done. So what this second system call does, it will notify to the down counter that it has done executing the up counting loop, and the down counting loop can start. So in the down counting, if you see, here also you have to create a lock and then wait in a loop until the up counting is done. So while not up done, here pthread condition wait ampersand done and the lock. So this loop will be executing until this up done will become 1. As you can see, it has completed this complete loop, and this variable, when it becomes 0, when it becomes 1, it will come out of this loop, and then it will unlock the lock and then perform the down counting, n minus 1 up to 0, and then this also sleep and execute. Other things remain the same. Just in the main, there is no change. You have to create two threads and make main thread wait for them and complete. So even though both the threads have sleep for 1 second, now the synchronization will happen perfectly, and you will see the code executing exactly before sync dot slash down. And we'll see the up counting is happening. This time the down counting is in the waiting loop because it is locked. And only after it completes the 9 digits, the down counting will start. 7, 6, 5, 4, 3, 2, 1. Okay. So you have to write the code to synchronize both the threads if there is a synchronization problem between the two threads. If they're using the same resource, like now both the threads are using the same monitor to display the output. So in this case, the two thread outputs will be mixed up if they are not properly synchronized. So it is your program logic that should make sure that the synchronization happens with the use of mutex variables. Okay. So more on how to pass certain attributes to the thread so that they have their own stack of certain size. They use particular type of scheduler. Okay. All that we shall see in the next session. All right. I'm sure you have picked up at least few points about what threads are, how to create them, and how to make two threads run in a synchronized manner. Okay. Yeah. So we shall stop today. On Monday, I'll again come back and see this synchronization part quickly with a little more details, and we shall also see how to use the thread attributes to decide the scheduler used and how much memory you can allocate to the stack and etc. All right. So we shall stop here. Thank you.
Yes, sir.